Welcome to another edition of this series Math for No Reason. In this edition, we will be looking at this problem of finding non-negative integer solutions of x1 plus x2 plus x3 is equal to 5. In particular, we are interested in knowing how many non-negative integer solutions are there of this equation. The method of counting through correspondence involves setting up a correspondence with another group of objects which is easy to count. So here we will be setting up a correspondence of solutions of this Diophantine equation with certain patterns which I will discuss shortly. Now let us observe that if we look at x1 is equal to 2, x2 equal to 2 and x3 equal to 1, then these three values satisfy the equation x1 plus x2 plus x3 equal to 5. Now we will set this up as a pattern of stars and slashes, and the pattern that we will be writing here is this one. If we look at another solution, say x1 is equal to 1, x2 is equal to 1 and x3 equal to 3, then the corresponding pattern would be, you would have by now guessed that what we are putting on the left hand side of the first slash corresponds to x1. What we are putting, that means the number of stars that we are putting in between the two slashes correspond to x2, and the number of stars to the right hand side of the final slash is x3. So if we write down this pattern, this will correspond to the solution. What would be this? You may have correctly guessed that in this case x1 is 2, x2 is 0 and x3 is 3. Since every solution has a corresponding pattern, therefore it is good for us to compute how many such patterns are there. Observe that there are 5 stars and 2 slashes. So a total of 7 objects. So if we look at these 7 places, each pattern can be created by putting slash in any 2 of these 7 places. So this one will give us the pattern which corresponds to 2, 1, 2. x1 is 2, x2 is 1 and x3 is 2. So depending on which two positions we are putting a slash, we will get a solution. Say if we put a slash here and a slash here, what we get is the solution x1 is 0, x2 is 5 and x3 is 0. So any two positions out of the 7 if we can choose, we will get a corresponding solution. And how many ways we can do that? So it is easy for you to observe that the number of patterns would be 7C2. There will be 7C2 distinct patterns here, and 7C2 solutions would also be there, because for each pattern there will be a corresponding solution. So the number of solutions is going to be 7C2, which is 7 into 6 by 2, that is 21. So there will be 21 non-negative integer solutions to the equation x1 plus x2 plus x3 equal to 5. What if I demanded that the solutions be all positive? Can you solve that? Thank you.